Hi students, today we are going to learn about simple regression using Excel. To start today's session, first we will look at what is correlation. So correlation we have already discussed in our previous video. So in correlation what we do is that we try to understand whether there is a relationship in between two variables considered. So we have discussed the correlation of coefficient, how to generate the scatter plot diagram. Those things we have already discussed. So today we are going to have the focus on the simple regression model. Before that, we would be understanding as to what is meant by a regression model. So a regression describes how an independent variable is numerically related to the dependent variable. So how a particular independent variable is numerically related to a dependent variable is simply known that as a regression model. Now we are going to focus first on the simple linear regression model. So the difference between the simple linear regression model and the multiple regression model is that in simple linear regression model we consider the relationship in between only one independent variable and the dependent variable, whereas in the multiple regression model you are going to consider two or more than two independent variables and its relationship with the particular dependent variable. So here in the first point it says the variable that analysts try to predict is called as the dependent variable. So here I am trying to differentiate what is the independent variable and what is the dependent variable. If the analysts try to predict a particular variable, we call it as the dependent variable, and the variable which you use for prediction, we call it as the independent variable. So this is very critical because if you don't identify your independent and the dependent variable in the correct manner, your regression model is going to be wrong. So be mindful of as to what is your dependent variable and what is your independent variable. So look at this regression model. Here you have y, which is the here you have y, which is your dependent variable. That is actually what you are going to predict. And here you have x, and which is the independent variable. For example, the money that you spend on advertising is dependent on the monthly sales. So monthly sales would be your dependent variable in that scenario, and x, or the independent variable, would be the amount that you have spent on advertising in a month. So what are these A, B? A, we simply known it as the intercept, the y-intercept, where the line is going to, where the trend line is going to intercept, is where we call it as the intercept. B is the slope, and E is, we call it as the error in the regression model. Look at this graph. So when you look at this graph, you can clearly identify this side you have the x-axis, this side you have the x-axis, and this side you have the y-axis. This is the regression line. So here, this is what we call as the intercept, where the line is going to intercept the y-axis. And the slope, look at the slope. So beta 1 is considered to be the slope. When x is going to get increased by 1 unit, what is the change in y? We call it as the slope. And you have the error term. Likewise, you can understand the graphical illustration here. So this you can read and understand. So here I have given the model, regression model, y equals beta 0 plus beta 1 x plus e. So what is meant by mu y? It is the mean value of the dependent variable when the value of independent variable is x. Beta 0 is the y-intercept, beta 1 is the slope. So what is meant by beta 1? It is the change, amount of increase or decrease in the mean value of y associated with 1 unit increase in x. When 1 unit of x is going to get increased, what would be the change in y? We call it as beta 1. And E is the error term that describes the effects on y of all factors other than value of independent variable x. So this x might not be the only factor that would be influencing y. There would be other factors. So that is explained through the error term. So why regression? In order to find to which extent variables are associated with each other. Now, since you have already learned about correlation and regression theory when it comes to your business statistics module, in this module what we try to do is that we are going to find how can we run a regression by using Excel. So first we'll look at this particular example. The example is the natural gas consumption case. So here it is mentioned. On the next slide, you get the average hourly outdoor temperature in a city during a week and the city's natural gas consumption during the week for each of 8 weeks. The temperature readings are expressed in degrees Fahrenheit and the natural gas consumptions are expressed in millions of cubic feet of natural gas denoted. So here we are given a case. What is the independent and the dependent variable? Independent variable is the average hourly outdoor temperature and the dependent variable is the city's natural gas consumption. So this is the data set given. So here when we are given the data set, okay, I am going to open the particular data set in Excel now. So this is the natural gas consumption. We look at what is given here. So first, what we try to do is that I am going to come up with the scatter diagram. So what I am going to do is I am going to follow these steps. First, we are going to develop the scatter diagram and the trend line in the particular scatter diagram. So this is our data set. So how can we generate the scatter diagram? Go to insert. This is the scatter diagram. Okay. Now we already have the scatter diagram but not for the correct data. So we are going to select the data accordingly. We will remove everything. Now we are going to add. So what are the x values here? X values has been so if you don't choose the x and y values correctly, your regression model is going to be wrong. So here x value is the average hourly outdoor temperature. So I am going to select the x values, alright, and then I am going to select the y values. So you have to select it, alright. So now we have selected the x and y values. Now okay. So here you can now see the scatter plot diagram, but there are some things missing, isn't it? You need to have the axis title, you need to have the chart title. So I'll add the axis title and first the chart title. We'll put the topic or the chart title as the natural gas consumption case. It would be more appropriate for us to put it as the scatter diagram okay. Alright. Now axis title. What is our y-axis? What do we have on y? Natural gas consumption. And we need to mention the units also. It's given in these units. And what is our x-axis? Average hourly temperature. Okay. Now we have our scatter diagram. So when you look at the scatter diagram, what kind of a relationship do you all see in between average hourly temperature, which is our independent variable, and natural gas consumption, which is our y variable? So we see there's a slope, there's a downward slope, which means that there seems to be a negative relationship. That ultimately means that when the average hourly temperature keeps on increasing, it seems like the natural gas consumption is keeps on decreasing. Alright? Okay. Now, what are we going to do? Here now, what we have to do is that I'm going to teach you two ways where you can come up with the regression model. First, since we have come up with the scatter diagram, we'll look at how we can generate the regression model by using the scatter plot itself. So, in order to take the regression model, using the scatter plot itself, go to add chart elements. There, go to more trend line options. So here, we are going to assume that there is a linear relationship. We are not going to assume about exponential kind of a relationship, but a linear relationship. So here, choose linear. So when you choose linear, you get the line here. Then we are going to ask Excel to display the equation for the particular data set on the chart itself, and we need to find we are going to ask Excel to display the R squared value also. So this would be the regression model and the R squared value for the given data set. Now we will look at what is the equation here. So you have y equals minus 0.1247x plus 15.644. So what is meant by this particular equation is that y is going to be the natural gas consumption, and minus 0.1247 is the, what do we call it? We call it as the correlation, we call it as the coefficient. So here, if we look at the model, look at here, it's more equal to this, y equals a plus bx. So b is the slope or the coefficient, a is the intercept. So what is the y-intercept here? It's 15.644. That simply means that when the x is 0, still there is a natural gas consumption of 15.644. So what is meant by 15.644 is that when x is 0, that means when the average hourly temperature is 0, still there is a gas consumption of 15.644. And what is meant by minus 0.124? So what is meant by 0.1247? It's the slope. It's the slope. So when x is going to get increased by 1 unit, there is a drop in the y by 0.1247. Why am I saying there is a drop? Because there is a negative coefficient here. Alright, so I hope the equation is clear for everyone. And what is meant by r squared value? We call this r squared value as the coefficient of determination. So what is meant by coefficient of determination is that to which extent does the variation of y variable is explained through the x variable. So there would be other x variables, there would be other independent variables explaining the same y variable, but here we have looked at only the average hourly temperature. So what is meant by r squared value here is that 91.16% of the variation of natural gas consumption is explained by the average hourly temperature. So again, this r squared value, when we are interpreting the value, we convert it into a percentage. So we say 91.16% of the variation in natural gas consumption is explained by the x variable, average hourly temperature. Is it clear? So here we have looked at one way that is available for you to come up with the regression model. Now we are going to look at another way. So this is by using the scatter diagram. In the part itself, we are going to come up with the trend line and the regression model accordingly. Now the second method, go to data and data analysis toolpath. So this data analysis toolpath is not readily available for you. So you have to check out my previous video on how to make this data analysis toolpath available. So it's an easy way. There's an easy way. If you can't remember, you can refer back the particular video. So if you have made data analysis toolpath available, go to data analysis. Here we are going to choose regression. Okay. So here I'm going to put the y variable. Here when I'm choosing the y variable, I'm going to choose it along with the label. If you want, you can choose it without the label. So here also with the label, I would be choosing x rate. So here, since I have chosen labels, I'm going to tick off labels. Confidence level, it would be 95%. Constant, here constant. So always you are not going to take this off. Here I'm going to take the output range here. Look at this. So here, this is another way for you to come up with the regression model without having the scatter plot, having this regression model in the scatter plot diagram itself. Okay, so it's a pretty large output, isn't it? So here don't worry, when it comes to the output that you are getting for the regression by using data analysis toolpath, you have to follow only 4 steps. Alright, so I'll show you the steps. So here in the slides also I have mentioned how you can come up with the output. So once after you have come up with the output, these are the steps. So what is the first step? First, you have to test for the significance of the regression model. So in order to check the significance of the regression model, you have to look at this value. So this is the regression for the model. So this is the significance for the regression model. It's 0.00022. So if this value is below 0.05, so here it says, if the p-value is below 0.05, we call that the regression model is significant. That means we are through the first step. So here we have a value which is below 0.05. That means the model that we have got is significant. Then we are going to look at test for significance of the independent variables. So here we are going to look at the significance of the independent variable. So here look at the significance of the independent variable and the intercept. This is also, these values are also below 0.05. So here we have 0.0002. It's no problem. The values are below 0.05. And here also you are getting 6.672753e, which means that e to the power 7. So here again this value is also below 0.05. So if you are not sure whether this value is below 0.05, choose this, click on this cell and look at the value here. See, value here in the formula bar. So it's very small value. Okay. So now we have looked at the significance for the regression model, and we have looked at the significance for the independent variable and the intercept. So they are also significant since they are below 0.05. Now you can come up with the regression equation. So I'll come up with the regression equation in this cell. So what is our y variable? Y variable is natural gas consumption. I'll put it as NGC, it means natural gas consumption, equals, what is our intercept? So intercept is, here we have the p-value of the intercept, here we have the intercept, it's 15.64413. Then we need to have the slope. Here we have the slope, but since we have a negative value, we will put it as minus 0.12465. And what is our x variable or the independent variable? Average hourly temperature. So this is our regression model. Alright. So check whether this model is the same model that you have got here. It's pretty much the same, isn't it? So here y, we have put it as natural gas consumption. Here the slope minus 0.1247. They have rounded it off for the fourth decimal point, and we have the intercept also. Look at the r squared value. So here r squared value, it's the same, isn't it? So here also you have got the same value. Here they have rounded it off again for the fourth decimal point, where here you have it for the sixth decimal point. So what is meant by this r squared value? It's the coefficient of determination. So what is meant by coefficient of determination is that normally we interpret it in percentage format. So 91.15% of the natural gas consumption, variation of the 91.15% variation in the natural gas consumption is explained through the average hourly temperature. So that is the interpretation of r squared value. I hope it's clear for you as to how you can come up with the regression model, the simple regression model, by using two methods. One is by using the scatter diagram itself. So by using the scatter diagram itself, by using the trend line option, you can come up with a regression model, or else you can use the data analysis tool pack. So it's very easy. I hope this exercise is clear for you. So you can refer the lecture slides, and all the instructions are given here. So since I have done one exercise for you, you can try the next exercise on your own. And also, when you are referring the slide, now since we have come up with the model here, now we have a model here. So if we want to predict, look at what is given here. It says to compute a point prediction of gas consumption when temperature is 40 Fahrenheit. So here it says that Excel analysis toolpack does not provide an option for computing point or interval predictions. A point prediction can be computed from regression results using Excel cell formulas. So here, if I want to predict what would be the gas consumption when the average hourly temperature is 40, this is how I can do it. So there is no such one option. So what you can do is that you can put the intercept value here. Intercept, what is the intercept? It's Control C. And next you can put the coefficient of the temperature. It was this one. So what I want to predict now is when this is the temperature coefficient. When the temperature is 40, I am going to predict what would be the gas consumption. So how can I predict it? Now I have the equation with me. So the gas consumption that would be when the temperature would be 40 is 15 minus, I am going to look at this particular formula for this particular regression model, minus so we will put it as plus. The reason why I am putting it as plus is because here the temperature coefficient I have already given it as minus value. But here if you have put the temperature coefficient in positive value, since in the regression model it's minus, you will be putting minus. So it's a pretty much simple mathematical operation. So here, and this time what is the average hourly temperature? We are going to check what would be the gas consumption when the average hourly temperature is 40. It's 10.658. So I hope it's clear for you. So likewise you can predict the value. So when the temperature is, we'll assume it's 50. So likewise, see. So that's it. So now since I have practiced one question for you, you can rewind it and see, and you can practice example 2. Here you have developed a scatter diagram. Based on the scatter diagram, you have to interpret as to what kind of relationship is there. Then you are going to use the data analysis toolpack and test for the significance of the regression model. So these things you have to practice. So I have uploaded the particular data set in the course web. So refer the data sets and do the practice questions. So if you have any questions, you can post it in the forum given. Okay, and also next week we are going to discuss about multiple regression, and also there would be a test based on multiple regression. So keep in touch with the course web. Stay safe and be happy.